A word you might hear a lot in programming circles is refactoring, which is the process of rewriting code to take advantage of things that you've learned since first writing the code. It's different to debugging and testing, which we'll cover later, because it's just about making your code work as well as possible. In the professional programming world, it's not uncommon to spend a lot of time working on a problem, trying different methods until you eventually find a method which works. And at that point, the problem is that your code is often not manageable and not readable, and often very brittle. And the process of refactoring can remove all of these problems. Refactoring is normally done towards the end of the programming cycle, so it's often the biggest thing to be impacted if your project runs late. I've heard some people who are very strongly against refactoring. They argue that it's just a waste of time because you're spending time not actively solving problems. You're just making your solutions more elegant, which is true. But it's also how you get to be a better programmer, by identifying any mistakes and ways to improve. If you're working on a project which will be used by thousands or millions of people, a small amount of improvement in the code can have significant impacts when you consider how many people are using the product. And so you often see people who are working on big projects defend their refactoring time a lot. It's also important to remember that you're not refactoring because your code is bad. You're refactoring because you want your code and your skills to be better than you are. Even the best programmers in the world refactor their code because they still want to get better at what they are doing. Fortunately, because we looked at methods and classes very early on, you'll hopefully have code which is spread out into a lot of small pieces of functionality. But imagine you hadn't done this. Imagine instead that all your code was in one giant method. It's a position that far too many people find themselves in. They have this spaghetti code which seems to have no end, and everything is so dependent on everything else that it seems impossible to change anything without breaking something else, which might seem completely unrelated. That's exactly the sort of thing that refactoring aims to eliminate. So how do you do it? There are plenty of ways out there, whether it's code review, where you and your friends or your team get together and talk through each other's codes as a group. You then explain why you've done something one way, and they try and think of alternatives which they discuss as a group. Whether you then go back and make a change is up to you, but at very least you will know an alternative method for the future. If you don't have a group of people who can help you, you can go back and look at the oldest pieces of code in your current project. You will almost certainly have learned something new since then, so see whether you can apply what you've learned to that code. Another method, if you're on your own, is to take a step back from your work and try and replicate a code review on your own. Try to think of alternative ways to achieve the same results on a line by line and also a method by method basis. As I mentioned earlier, remember that refactoring is not only a time to both improve the code you've already written, but also a time to improve your own skills. As well as improving your code, a significant part of refactoring is looking for errors. There are a couple of different types of error that you should be aware of. We have syntax errors, which are probably the easiest to spot. Your program won't run at all if you have a syntax error, and you will receive red warning messages in Eclipse. Examples are missing semicolons, missing or mismatched brackets or curly braces, etc. We also have runtime errors, and these happen when the program is running. The error message for these can sometimes make it easy to fix, and on other occasions make it not so easy to fix. Examples are trying to add a string to a variable designated as an integer, for example. We also have logical errors. These are probably the most difficult to spot. And this happens when what you're doing is allowed by Java, but wrong in the real world. For example, you could be saying that there are 12 months in a year and 4 weeks in a month, so there's therefore 48 weeks in a year, which is obviously incorrect. There's not really anything else to say about errors other than you should be aware of all three types, because you will almost certainly encounter them when you're programming.